So it is not quite possible. So we will not see this type of isomerism also in this alkyl halide. Hello everyone, welcome back to PLUTUS STEM. And in the series we were discussing regarding the haloalkane and haloaryl, in which we have discussed what are these haloalkane, what is the basic, why we are studying these haloalkane and haloaryl. And today we are going to discuss regarding the isomerism in this haloalkane and haloaryl. Yeah. So first we are going to start with the haloalkane. So actually this topic is being studied in our class 11 itself in quite detail, but in the next chapter we are going to discuss regarding the preparation and properties most probably. So just give you a view about this isomerism thing also. So I thought that this will be a quick revision of all the isomerism which we have studied in the class 11. Yes. So yeah, as we know, there are how many type of isomerisms are there? We know structural and stereo. Which why I am drawing this again and again, just to make you understand which type of isomerism we are going to see in this haloalkane and haloaryl. So this structural isomerism, we will see position isomers. We will see chain isomers. We will not see metamers, because if you are being asked that tell me about the metamers in this haloalkane, given haloalkane or given alkyl halide, so the answer is going to be 0. Why? Because metamers are being found in those compound, those functional group which are divalent, and this is a monovalent functional group. So this will be not shown by this functional group isomerism. So functional group isomerism is a type of isomerism in which we have the same molecular formula but the different structural formula on the basis of different functional group. But if you are having Cl, on the basis of Cl, we can't have any different functional group without replacing this. So it is not quite possible. So we will not see this type of isomerism also in this alkyl halide. Based on these alkyl halide, functional isomerism and metamerism and tautomerism. Tautomerism is generally shown by ketone, aldehyde and cyanide triad system, diet system. That also we are going to study in quite detail in the upcoming lecture here. So these two isomers we are going to see from these you can say structural isomer. Generally in our exam we are going to we are being asked that tell us the structural isomer of this compound. So we have to focus only on these two, number one, number two. So we are not going to go into the detail of this, because not these isomers are not being present in this alkyl halide and aryl halide, or you can say haloalkane and haloaryl. So yes, coming to this, so this is methane CH4, and if we remove one hydrogen from here, we get CH3. This is methane, this is methyl, and at this if we are going to add some substituent, let's say our halide CH3X, so it became alkyl halide, or you can say over here we are given with methyl halide. So if you see the IPAC name, we have seen in this isomerism when we have discussed regarding general. So we have seen starting 3 membered methane, ethane and propane, they don't have any isomers. So this methane don't have any isomers, In the same way for CH3, single bond CH3, this is our ethane. After removal of one hydrogen either from this side or from this side, both the hydrogen are same. Both the hydrogen are same. So you can remove the hydrogen from any side. It will give us CH3, CH2 like this. So it's ethyl, the ethyl, and no isomers. No isomers. So it will give rise to CH3, CH2X, ethyl halide or haloethane. Haloethane. So like this, yeah. And the next member is, why I am drawing this? Because in this propane we have seen, in this propane we know there is zero structural isomers. This zero structural isomers of propane we have seen, but when we will talk about the alkyl halide, we will see there will be some isomers we are going to see of this C3H7. This C6, C3H8, when one hydrogen is being removed, it became CS3, CS2, CS2 like this. One possibility is this. This is normal propyl. And another possibility which we are going to see over here is, if we take this hydrogen and this hydrogen are quite different, it will give us CS3, CS3, CH like this. And this is an isopropyl. So due to these different hydrogen, so we are having zero isomers, or you can say no isomer of propane. But when the talk about this alkyl halide, so we will see two isomers. One when the halogen is attached at this side, another when the halogen is attached at this side. X. So it will be like propyl halide or halopropane, or it will be like CS3, CH, CS3X. So it will be like isopropyl halide. So these two isomers, isomer number 1, isomer number 2. So these are the two isomers which we can see from this haloalkane, and both of them are this is the principal chain. If you give the IPAC naming 1, 2, 3, and here also the principal chain is this one only 1, 2, 3. So both of them are positional isomers because the chain is same and the position of this halogen is changing. Position of this functional group is changing. That's why we call it as a positional isomers. So now we will see some more example of the CH3, CH. It can be bromine or CH3, CH2, CH2, bromine. It is ethyl bromide, propyl bromide. Which propyl? Isopropyl. And this is normal propyl, N-propyl. Why we are writing N? Because there is another possibility. Now two possibilities are there. One is iso, another is normal. So that's why we are writing over here N. Normal propyl bromide, and any halogen can be attached over here. And so this is the general thing. We can see any halide, any propyl halide is going to have two isomers. How many structural isomers? Two structural isomers. And if you talk about the position isomers, that is 2, chain isomers, that is 0. Total isomers, total structural isomers is going to be 2. This is the thing which we have seen in this. Clear? Now, when we have a CH4, CH3, CH2, CH2, CH3. This is our butane. This is our butane molecule, and we have seen regarding this butane molecule how many isomer. For carbon 4, we have seen C4 has 2 isomers. C4 has 2 isomers, and if we draw another isomer, that was like this. Like this or not? These two were the isomers. When we talk about the hydrocarbons, these two isomers we have seen. Yes or no? But when we talk about regarding these halides, so from this, how many possibilities are originating? These two hydrogen are same, so we can have halide like this, alkyl like this, CH3, CH2, CH2, and CH2 like this. One alkyl like this. So this is normal butyl. And another alkyl which we are going to see when we remove the hydrogen from this side. It will be like CH3, CH single bond, CH2, CH3. This one. So this is going to be which butyl? Can we term it as a isobutyl? No, because it is not being generated from isobutane. So it is not named as isobutyl. So it is not necessary that every hydrocarbon or every compound have their common name. Clear? This we can call it secondary alkyl or secondary butyl. 4 carbon are there, so we can call it as secondary butyl. So 2 possibilities from here, and if you see regarding from here again, this will also give rise to one possibility from this side and another possibility from this side. So because these 3 are same now, CH3, CH, CH2 and CH3. Clear? This compound and another compound, this one, if you see regarding this, so this will be having now CH3, CH3, CH3 and this one, tertiary butyl. So these are the 4 possibilities we are seeing. 4 alkyl substituent we can see. So these, if we attach halogen over here this side, okay, no, halogen at this side, halogen at this side and halogen at this side. So how many isomer you can see from this carbon 4? Can you count this or not? 4 isomers possible or not? I have shown you over here. So there are 4 structural isomers of this alkyl halide. So if we draw it like this, one is Cl at the center, another we have drawn Cl at the center, third one we have drawn, okay, so yes, like this, Cl at the center, and the fourth one we have drawn propane, methane, ethane, propane, and Cl at this center. These were the 4 group or not? You can see. If you are having any doubt, I will just cross check. This was the worst one. 1, 2, 3, 4 carbon. This one. 1, 2, 3, 4. And regarding this, 1, 2, 3, 4. This is this one. 1, 2, 3, 4. Regarding this one, sorry. Regarding this one, 1, 2, 3. 3. Regarding this one, 1, 2, 3. This is like this one, 1, 2, 3. 1, 2, 3. Clear or not? The longest chain. So these are the four different isomers, structural isomers of 4 carbon which are being attached with this halogen. So these 4 possibilities I have shown you over here. Is it clear or not? So one thing we can see over here, one more thing which I can show you over here. This one and this one. These two are position isomers. Clear? And these two are this is the whole chain, parent chain, the position of Cl and position. The chain is changing this time or not? Chain is changing or not? The main chain is like you can say is quietly, or you can this propane and this is also propane. So these two Cl at this position, second, and at that time Cl is at second position, CH3 position. This is quite same. This whole group, if you see, the whole moiety is same. Only this is changing. Cl position at this center and Cl position at this center. So we can say these two are position isomers. So 2 position isomers upside and 2 position isomers are over there. Total 4 position isomers are there. And if you see the chain isomer, this one and this one, these are chain isomers. This one and this one, they are chain isomers. Yes or no? This one and this one, they are chain isomers. This one and this one, they are chain isomers. Yes or no? Different chain, different chain, different chain, different chain. Yes or no? So this is the way how we can see, how we can assume these compound. Different chain, those two are having different chain. These two are also having different chain. These two are also having different chain. So in this way, the total structural isomer. Generally, we are not going to ask in the exam that how many chain isomers are there. Generally, you will be asked total structural isomers. That will be 4. Your answer is going to be 4. Up to this carbon 4, it is quite easy to draw also. You can just find out. But when we will go into the carbon 5, CS3, CS2, 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 CS3. 1, 2, 3, 4, 5. So do you remember how many isomers we have drawn for the carbon number 5? There were 3 isomers. How many isomers? 3 isomers. One is this one. Another is CS3, CS2, 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 and CS3. Third one, second one, clear? Third one was CS3, CS2, CS3, CS3 and CS3. Clear or not this thing? So these were the 3 isomers. And from these 3 structural isomers, we can find out some more possibilities. So there will be how many possibilities? 8. How many possibility of alkyl halide? There is going to be 8 more possibilities. How we can calculate this? By different hydrogen. This and this is same, 1 hydrogen. This and this is same, 2 hydrogen. This is say different, 3rd hydrogen. In this compound, this one and this one, they are same, 1 isomer only. This is different, 2 isomer, 3rd isomer. Yes or no? This will give 4 isomer. Yes or no? Clear or not this thing? And regarding this, all these are same, so only one isomers from all these. So total isomer you can count out 1 from this, 4 from this, 3 from this. So total isomers which we are going to see are only 8. How many isomers? 8. Either you can see from this way, or you can simply learn also. These isomers value, just to draw this, that. So I will just tell you in the when I will complete this session, I will just provide you how many structural isomers are there for methane, ethane, propane, butane, pentane, hexane, up to like 8-member chain or 10. And regarding these alkyl halide also, methyl, ethyl, propyl, butyl, pentyl, hexyl. So how many structural isomers are going to be present in this compound? So if you can remember, if you are quick in remembering these things, so you can just within a fraction of second, just by visualizing the question, you can just tick that the right answer. And if you are not that much good at memory, then also I have told you, explained you the whole concept, how you can draw these isomers quite easily. Just you need to know the main parent chain and from where they are being originated and how we can draw these isomers. Yeah. For these carbon number 5, these are 5 carbon number 5. So firstly we will try to draw the isomer of this. If halides are being attached, let's say halogen is attached at this center, or it would be better if we attach it to this side because it will save our space. Yes. So it will be numbering like 1, 2, 3, 4, 5. Another possibility will be this one, and the halogen is attached at this center. Clear? Second one, third one is going to be this one. 1, 2, 3. 1, 2, 3. All the three. The relation between all these three isomers is going to be position isomer because the chain is same. Yes or no? Only the position is changing in all these examples. So we can say that these are positional isomers. These are positional isomers. 3 positional isomers we have drawn for this carbon 5 as I have shown you over here. How many possibilities? 3. I have drawn this 3. Yes or no? Now we will see for this. Yes, now for this one, if we add up, so first possibility is we can add Cl at this side. Any halogen we are taking X, so it would be better we will take X only. Otherwise, it will create some unnecessary issue. Over here, we can have X over this side. Now we can also have X at this side. Yes or no? 3 isomers. We can have X at this side. 4 isomer. Clear or not? Is it possible or not? Is this isomer possible or not? Tell me. Are this and this same? This and this are same. Either at this position or at this position. These both position are same. So that's why it is not possible. We can't draw this. Clear or not? Don't do such mistakes. Don't even try to do such mistakes. Yes. This is a separate. So now we have drawn how many? 4. Position 1, 2, 3, 4. 1, 2, 3, 4. 1, sorry. Yes, the numbering will be like from where? 1, 2, 3, 4. 1, 2, 3, 4. 2 methyl. Here 2 methyl. Here the methyl is at 3. Here the methyl is 3, but halogen position is changing. So this is the way how we can draw 4 isomers. Possible over here? 3 positional isomers. 1, 2, 3 we have drawn from here. And the last one is from this one. That is going to be Cl. CS3 and this is CS2. Clear? So these are the 8 isomers which we have drawn. If you are getting some confused regarding this is like this 1, 2, 3 and like this. Clear? CS3, 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 and CS2, CS. So anyway, you can draw. The structure is not, or simply if you want to draw, this can be like this: CS3, 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 CS2, Cl or X, whatever be the. We are taking X, so we can just see. It is better if we take X only. Clear? So this is the way. The principal chain over here will be this one, on which the halogen is being attached. So this is the way how we can uh, know these isomers. So now I will just give you a quick revision of all the halides which we have seen. Methyl halide, ethyl halide, propyl halide, butyl halide, pentyl halide. These are the 5 we have seen. Yes or no? Yes. So what we are going to see, how many isomers are going to be formed. We are not going to, I've just drawn this, we have taken around half an hour just to draw all these structure. So within a fraction of second, you can just tell how many isomers are present, structural isomers. 0, 0, 2, 4, 8. Yes or no? 0, 0, 2, 4, 8 structural isomers. Structural isomers of all these. And after that, I don't think in your exam it's going to be, you can draw for a higher member also, but it will be quite complicated also, and they are not doing, from your exam point of view, it is not that much necessary. So this is for your halides, the isomerism. Clear? Now one more thing, if you need to know regarding the halogen, if you are not, I think that is quite easy trick for you. That would be much better if you don't need to do this trick. You don't need to remember. Then the easiest way I have shown you. Just know this thing. The parent chain. If you know, you should draw the isomer, parent chain isomer, and then add the halide over there, and you will get the exact number of isomers, structural isomers. Clear? This was for you can say alkyl halide. Now we will see for aryl halide. Aryl halide. This is the benzene ring. and here some halogen is being added, monohalogen. So what does the name of this compound? We call it at halobenzene, halo, haloarine, or aryl halide. So various ways are there to represent the name of. And for monohalogen, we don't have any like you can say isomers in this case, because the position is fixed. You can't have much more position if you try to do this. Yes, I am having this one. So this, from here the numbering start at this point. In this structure the numbering start at this point, and these two are same compound. They are not the isomer, they are the same compound. So this type of isomers we are going to see in dihalo compound. If we are having a dihalo compound, this one and this one, it is ortho dichlorobenzene. Yes or no? This position is ortho. If you are not knowing, I will just make you a quick revision of that also. This position is ortho, this position is meta, and this position is para. First position, second position, and third position. Clear? These are ortho, meta, and para. So at ortho position, this ortho and this ortho dichloro, two chloro are there, benzene. If you want to draw the isomer of this, we can have an isomer, positional isomers. This Cl and this Cl. This Cl and this Cl. So this is now meta dichloro benzene. And the third one will be Cl and Cl. Any benzene we can take, any halogen we can take, alkyl, oh sorry, fluorine, chlorine, bromine. I am just taking the example of chloro from here. Yes. This will be para dichloro benzene. So that's all for like generally we see this type of isomerism in this aryl halide. And now if you are not, I've just shown you this positional isomers and chain isomers, and after that another class starts, stereoisomers. I have left this section. In this we have conformational and configurational. In configurational we will have eclipse, staggered. In the configurational we will have optical isomers and geometrical isomers. So we will see, are these possible in this halogen? Yes. We will see all these eclipse, staggered, optical, geometrical. Just I will, we have already studied regarding these in quite detailed in GOC part in class 11. You can go over there and watch the lecture, but I will just make you a quick revision if you have studied, so that you can know that if you are not getting the point, just to give you a glimpse of that, I am letting you know conformational isomers, in this hydrogen, 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 halogen, hydrogen, hydrogen. Which compound is this? Can you name this compound or not? Just try to name this. Hydrogen, hydrogen, hydrogen. X, hydrogen, hydrogen. So if we name this compound, this is carbon 1, and one carbon is backside, carbon 2, CH3, CH2, which means ethane, or you can call ethyl, and that is halide. This is also ethyl halide. But these ethyl halide, they are having like this. If you see, this is carbon 1, this is one hydrogen, this is another hydrogen, and one hydrogen is going below the side. This is for the front carbon. In this side also, this side also. But if you see regarding halogen, in this we are seeing one hydrogen, halogen at the back side. This is the structure over here. But here, these hydrogen rotates. This come over here, this come over, it's coming over here. This one is going over there. So like this. Here is the rotation of these hydrogen. We are going to see some rotation in these hydrogen. I will show you how these hydrogen are rotating. This one is upside. What will do after some time, it will this like this. They are like this, they will become like this. So like this, the rotation we are going to see over here. So this type of rotation, they are giving the different conformation of these compound, which means these two cannot, they are not separable. We can't separate out these two conformation, but they exist in within a molecule. So we study these, and these type of isomers are known as conformational isomers, and this is ethyl halide in staggered conformation, and if they are aligned one to each other, then they are termed as eclipse. Eclipse, and this one is staggered. Clear? So this is the thing, and why this one is stable, that one is stable. So generally, by simple visualizing, we can say this is quite stable and this is less stable, the staggering, due to the hindrance. But there are some other factor we will see, some more factor like hydrogen bonding, this and that. So that will also play a role. That sometime we will see that eclipse is stable or staggered or gauche is stable. So that all thing we have discussed in a quite detail in class 11th. You can go over there and watch the lecture of GOC, conformational isomers. So these are present in these. And regarding the configurational isomers, generally these are of two types: geometrical isomers, the isomers which we are seeing in a double bonded carbon, restricted rotation. This is X, this is X, and these are hydrogen, this is hydrogen, and another possibility is this is X, this is hydrogen, again X, and this is hydrogen. So if you see over here, these are nearby and they are quite far. So this type of, when they are on the same side of a double bond, they are called as cis isomers, and they are termed as trans isomers. In general way, these are trans is more stable than cis. So here also some other factor also plays role. So we can see that this type of isomerism is also possible in this haloalkane and haloarine. I have shown you over here with a simple example. So you can see put other possibilities, other molecules over here. This halogen can be replaced with another you can say chlorine, bromine, iodine. So all are going to show you this geometrical isomers. And the lastly, we are going to discuss regarding the configurational isomer, that is optical isomers. In this optical isomers, we are going to see that C2H5, CS3, this is X, this is hydrogen. C2H5, CS3, this is hydrogen, this is H. So if you see over here, the higher molecular mass compound is given as priority 1, priority 2, priority 3, priority 4, priority 1, sorry, priority 1, priority 2, priority 3. And we do a rotation from 1 to 3. We do a rotation from 1 to 3. Both are anti-clockwise. If anti-clockwise rotation is there and the fourth group is below the plane, then we call it as a S configuration. And when fourth group is above the plane, we call it as a R configuration. So this is the way how we name this R configuration and S configuration. So this is for your, you can say, configurational isomers, R isomers, and this S isomers. Sometimes we will have like diastereomers, enantiomers. Enantiomers are like, they are non-superimposable mirror image of each other. Both the isomers are non-superimposable mirror image. But diastereomer, they are not the mirror image. Yes, clear. So this thing we are going to see, we have already studied this thing in GOC. You can go over there and watch the lecture in quite detail. So just I will get you a quick review what we have studied in today's class. We have started with isomerism. Firstly, I have classified how which type of isomers which we are going to see over here: position and chain, conformational, configurational, eclipse, staggered. So all these position, chain, eclipse, staggered, optical, and geometrical. I have shown you with a very quick time. I just explained you, and I have also told you that these isomers are not possible in this haloalkane and haloarine. So this is the way how we have seen. I have drawn you all the initial members, their isomers we have drawn, and I have summarized also all this thing. That if you don't want to do this drawing thing, you are not comfortable in this drawing, you can just simply learn. This trick is going to be 100% accurate. You can just simply pick up this number and put, if you are having any of this propyl, butyl, pentyl halide, bromine, anything can be, it can be anything. Yeah. Remember, it is for structural isomers. Making clear it structural isomer. Clear? After that, we have seen the positional isomers in this aryl halide also, a bit more, conformational isomers and configurational isomers. So that's all for this cis trans, and in the next upcoming lecture, we will be discussing regarding the nomenclature of alkyl and aryl halide. This we are going to discuss. So we continue to this series. We will be discussing the nomenclature with a very quickly. We will be discussing, because this is also being studied in class 11. But to start with, it is quite better if we quickly revise all these nomenclature of alkyl and aryl halide. That's all for today. Thank you.